Good morning, afternoon, and or evening, depending upon when you're watching this. I'm going to start with the visual for the output of my code. We have the tape on the bottom that I held, the tape attached to the two surfaces. The yellow arrow is the electrical force of A on B, and then the red arrow is the force of gravity on B. So, starting at the outputs here, I output the mass of tape B, the distance between the two, which was 3 centimeters in my case, the gravitational force on B, the electric force of A on B, the charge of tape B in coulombs, which was my calculation as the equal but opposite of the force of gravity, and then the number of electrons on the surface of the tape, and then the ratio of electrons to atoms on tape B's surface. Now, looking at the program, I start with constants, the 1 over 4 pi E naught, the charge of an electron in coulombs, all the units are on the right here, commented out. The length of my piece of tape, which was close to, I think, 8 inches, which translated to 0.2032 meters. The gravitational constant, this was from Campus Wire, the mass of the tape per length. I converted it to kilograms per meter for easier calculations. My scale factor, the distance in between the two, the length of an atom given from the PDF in angstroms converted to meters, the area of an atom based on that length scale, my tape width in meters, and the tape area, which was a constant in this case, from the tape width and the tape length above. I initiated two objects, tape A and tape B. In my case, I put tape A at the origin and had a small radius with tape B 3 centimeters above that. I initiated the observation location, and then I calculated R from the observation location to tape B, and then I found the magnitude of that vector and the unit vector. After that, I found the mass of tape by taking the length of the tape times the density length value of the tape, giving us a mass, which was in the output. Then I have the force of gravity, which was the mass of the tape times gravity, and in my case, the y direction is pointing downwards from tape B to tape A, that's why it's negative. QB, which was the charge of B as a whole, I guess as a point charge, was from us equating the force of gravity to the force of A on B, and then solving for the charge of B, which was equal to A as one of our assumptions, that the charge of tape A was equal to the charge of tape B, allowing us to solve this problem. And then further downwards, I have the number of electrons as the total charge of A divided by the charge of an electron. And then if we take the tape area, dividing it by the area of an atom, that gives us the number of atoms over the surface of the tape. And then the ratio of the number of electrons on the surface of the tape to the number of atoms is given by this. And then here I just have the outputs for labeling, labeling which one is tape A, tape B, the force of gravity, and the force of A on B. And then these are the printing outputs for all of the nice text down there. This puts the arrows on the visual, and that about wraps it up. I'll go back so you can look at it one more time after seeing the code. And I guess the main summary of this lab was to conduct an experiment to kind of figure out the general charge on everyday items, the effect of polarizing them by moving two things apart, and then getting a better understanding of the way charges attract and repel one another.